Hi, David here. We're back again with the Sparrow Scout. This is the build video and going to show all the how to assemble it. And if you want to see a little bit of the flying of the final version here, go ahead and fast track to the end. Please stick around, and if you're enjoying this content, please subscribe, like it, and if you have questions, comment, post up, and I'd love to hear what you're doing. The Sparrow Scout RC plane is available on Printables.com in my Printables store. If you follow the link down below in the description, you can purchase for $5 the plans, including the two-dimensional CAD file where you can modify the kit, the foam. Also, all of the 3D files are available. There are also the tiled PDF for A4 and US letter, and a full PDF plan if you want to view it all together. So I don't know about you, but when I see all these parts like this, the motors, ESCs, servos, wheels, all the hardware, my heart starts pumping and I get pretty excited. So I hope you're the same. I got foam board that's cut by my buddy. Let's jump in. So the parts I'm going to be using are the recommended parts that are listed on the Printables.com website. I will go over these individually, but if you want to see what I'm using, go ahead and look at that listing. All the links are provided there, including for the landing gear, motor, ESC, props, servos. Some of the connectors I'll make sure I include, screws, the nuts, some of the bolts as well. This is the prototype wing that we've been flying on the Sparrow Scout, and I'm going to build another one for this build. This was regular paper foam board from Dollar Tree. We're going to be using the ready-made foam from Flight Test. We're going to rebuild this and do another one. We're not going to include that in the build because there is our video already on how to build the slow stick wing, and it is built exactly the same way. So if you go watch the link below for how to build the slow stick wing, it's the exact same parts, and the joiners and the carbon that is leading edge and trailing edge of this wing. There are extra parts in here because you have different options for the build. Different camera mounts for the different kind of camera bases that you might be using. Also, there are the long format struts. These are what I used on the original build that I've been flying. They work great, especially if you want to go for a larger prop, 10 to 11 inch prop. This build, I'm going to use the short version, and these are also shared with the files on Printables.com. And these are about an inch shorter from the arrow shafts, and we'll go over that. This will lower the wing a little bit. I'm interested in seeing how it's going to fly. 3D printed parts are all done in matte PLA. That's what I prefer. It has a good tensile strength as well as pretty pliable and easy to print. So as far as the wheels, they're done out of the PLA, matte PLA as well. But the tires are TPU, and they are hollow, 0% infill. And that makes a real tire. It's pretty cool. We'll go ahead and get that on the rim. And that was the easy way. But basically you just take the tire on the outside. And those are snug enough into the rims that they will just stay. The core of this airplane is built upon the carbon fiber arrow shafts. And the links for these are down below as well, or listed on the Printables.com listing. They are basically a 31-inch long. We will not be trimming them. We'll just be removing the feathers and using the full length. These arrow shafts are threaded. Make sure that you put the threaded ends at the front. We will start by adding the trailing edge strut. After getting the trailing edge strut in place, add the servo trays. This will be the tray to hold the servos. And these will go with the flat side up on top of the booms. Please note that there is a front and back to these. Next, we'll add the leading edge strut, the landing gear mount, battery tray, then the nose cap. You'll want to make sure that everything is straight and flush, that the rods are in all the way and parallel. It's important to note that these are designed to be butted up against each other. However, you may add a little bit more space in there if you desire. But the idea is to have about 19 centimeters from the nose here to where the strut begins. This is the wire guide that helps prevent the control wires from bending too much, and it guides them back to the elevator and the rudder. And put this on the tail. These are the bolts that will go into the threading of the arrow shaft. I'm using 8-32. That's American threading. I got these from Home Depot, and they're 1 inch long. Go ahead and snug these down, but there's no need to over tighten them. We want to make sure that the length is equal between the two. And you can always check that the back end of the arrow shafts are equal. In preparing the steerable tail wheel, we'll need to drill to match the gauge of the wire that you've chosen to use. In this case, this is a 2mm wire. Perfect. The tail wheel mount can be snapped in or slid in, but it'll go in this place and we will secure it after we get the tail assembly in. Next, this is the leading edge for the tail wheel, and it'll slide on the shaft. Be careful putting this on, don't squeeze these parts. Next is the bottom plate for the tail. Again, push it along by the solid part by the holes. Now this piece should end right at the carbon arrows, or close to it. I'm going to end mine about right there. This will go on top of the foam to hold it down as a washer and a guide for the vertical stabilizer. This is the aluminum landing gear that I recommend for this kit. The link is also on Printables.com in the listing. And it comes with the gear for the nose as well. If you want to do a trike landing gear, this kit, we're just going to use the mains. You can use these wheels if you want, but I like the taller 3D printed ones that we 3D printed earlier. What I like about this landing gear kit is that it comes with most of the hardware that we will need, including the 3mm axles that will mount into the aluminum, and the wheel collars to keep the wheels on as well. I just put them on there for safekeeping for now. On the PDF plans, we show the cockpit, but there's some lines that are red that are not intended to be cut all the way through, and I'll show those here. It's right here, here. This is the bottom of the cockpit. This front section, the paper will be removed. Now, the reason for this is that the foam board will fold better without having the crinkles and things in it. It'll be smoother in the curves. We're going to build the cockpit now, so I'm going to just cut those pieces out, and keep in mind those sections that you're going to remove the paper only on the inside of the curve. When wanting to fold this foam and removing the paper from one side, just take it to the table edge and you can just kind of run it across here. So now you can just hold it easily with your fingers and it has a nice round curve to it. Do the same thing for the nose. We need to put a crease right here on the inside. So we line up where it's going to be glued, and then right here. We'll do the same to the other side. We'll start gluing this. Lay a bead of hot glue along this edge, and then we'll glue the nose after. Close it up. And the important part is the panel for the cockpit. This is just printed. I shared the file. It's one of the photos shared with the listing, and you can download that. If you do it at 100% size, it's 100 millimeters this way. I put a clip piece of clear tape over the top of it. And I like to recess it just a little bit in there. So just test fit it, and then we'll glue that in. Now we're going to test fit the fuselage or the cockpit with the booms here. What I like to do is just line up the front on the cut line and just put the screws are going to go, or the bolts will go right through that line. That'll line up the back parts to go in their proper place. And at this point, just find the center line the best you can, and then mark the holes, punch the holes, and put the screws in. You don't need to over tighten these, just snug them down. This will allow you to take off this fuselage to work on it if you need, replace parts if needed. I'm using 3M bolts that I have to mount these, and I pre-punctured those holes, and we want to get the main landing gear on now. So. I'll add blue Loctite on here as well, so that these nuts won't vibrate off. We're going to prepare the tail wheel so it'll fit your selected tail wheel wire. And that'll be perfect. I'm going to bend the wire for the tail wheel, and it doesn't have to be very long. I just did it there. So tail wheel is going to go on here, and then we're going to cut it about here, put it into the pipe. Just a slight bend back, right there. Now, the secret to the control horn is there's a hole in one side, and that's going to be for the set screw. The best way to do this is to put a longer set screw that's in the same threading as this collar so that it sticks out through this hole and you can adjust it. I don't have any right now that fit that, so I'm going to secure it in there, get it in there, and then I'm going to lock it in with some glue. When mounting this, you want the wheel to be as straight as you can and have the horn coming straight out the side. You can adjust the steering by the length of the wire that goes to this control horn. So it's okay if it's set. They're the MG90D servos. They're digital and they're metal gear. They actually are pretty smooth and pretty good for the size of an airplane. Before securing down the control horns on the servos, it is a good idea to center the servos, and I have a servo centerer here that I made. And you can get these almost anywhere, any hobby shop or online. It runs the circuit when I hold the button, and when I let go, they auto center. For the horizontal stabilizer and elevator, you can cut it from the foam board, leave it attached as best you can. We'll tape one side if needed, and then hinge the other side. For the tail, only cut part way through so that you don't cut the whole tail off. You can if you want, but if you do, just tape it back on. But I found this is a great way to keep it square, and it's actually great for doing a speed build. So you can just start to crack that if you've just cut part way through. We do need to cut a relief on the back side of this, so I just fold it back, and then we'll cut a diagonal across this edge. So it's down and up. Continuing with the horizontal stabilizer and the elevator, mark the center line by measuring and finding the center line. The other thing I like to do is you either use carbon fiber or nature's carbon fiber. I like to add a little bit of a hard edge to the leading edge, and that just stiffens it up a little bit, but also if you get any dings against it, it prevents it from ripping into the foam. And just center that the best you can. I also like to apply tape down the center line, top and bottom, where the bolt holes are going to attach it to the fuselage. That way it'll hold a little bit more secure. We can now add it to the fuselage. Lining up on the center again. Punch that, put the screw hole through, and then adjust it. So we can snug that around. Once we get that down, we can slide that back to where the tailpiece ends right there. You want to snip this too. The vertical stabilizer, just like the horizontal, has a cut line that goes partway through to give you the rudder. You just crack it, just like that. And that's all the deflection you'll need. Just like with the elevator on the center, I like to add tape where the bolts are going to go. Just test fitting. Once you get it where you want it to go, punch it and put the bolts in. This is how we want it in the back. Lots of room for the elevator hinge. And then punch this through. And we should be good. Now this should be snug, but not over tight. It's just going to hold that thing in place. When placing this on, make sure there's enough room for this hinge to go. When this is lined up right, the back edge of the rudder and the back edge of the elevator are almost aligned perfectly. Now we can secure down tail wheel assembly to the sticks using zip ties. This is the D2836 and 1120 kV. These are the 1/4 inch by 20 common US nuts. It's the same threading that is common on the bottom of most camera mounts and cameras, but you just get this in here. This is designed to be pressure fit in there. Put them both in there. They'll line up with the holes and you should be good. These are the control horns, and we're going to put them on the elevator and the rudder. When adding the 5mm wooden dowel or carbon fiber, test fit your wing in here first. That'll set the distance, and in this case mine's about 23-24 centimeters. So I'm going to go ahead and cut that. The servo push rods have been installed. I use these Easy Connects right here. I'm using the 1.8mm diameter hole, and these push rods I think are 1.5 or 1.6mm in diameter, and that's the music wire or piano wire. Also, I link off of the rudder channel to the tail wheel, so when the rudder moves, the tail will move with it. If I need to adjust the tail wheel with the rudder, I can just loosen this and slide the tail wheel back and forth until I set it where I want it. I'm using packing tape from Amazon. This is the 30 amp ESC, the electronic speed controller that I recommend. The link is down below, but it comes all wired for the XT60 plug and ready for the motor. This is the 6-channel TBS Crossfire receiver with a 900 megahertz receiver and antenna. I use this for long range so that I don't have to worry about outflying the video in FPV. I have made my own expansion board and then broke out the channels for up to 6 channels. Depending on what radio system you're using will depend on where you put your servos. I'm using channel 1 for ailerons, and so you will put the rudder servo on the aileron channel for your radio, which on mine is channel 1. And the elevator servo will go on channel 2. So this is your basic 3-channel setup because we only have rudder and elevator. Using channels 1 through 3. Channel 4 will be for the pan on the servo, for the camera, and I will use channel 5 to arm and disarm through my OSD. We now can test the radio along with the ESC. So the elevator should move with the right stick. Pull back, it moves up, forward and down. The aileron or the roll channel is hooked up to the rudder. And that's a left turn, and it turns to the right. And the motor should spin the direction that your prop wants to spin. The camera tray, there's a couple of options. I've built the ones that I typically use. This is for the full and original DJI air unit. This is the 180-degree servo that I like to use for the pan on the camera. I've been very pleased with it. It claims to be digital metal gear. Okay, I added the camera, which is the original DJI air unit camera. And the air unit, courtesy of Scott up in Sedona. Thanks a lot, Scott. Eight by 6 prop, and mount it so the curve is at the front. Before we get into the flight, I just want to show a few things about this build. The only things that are different from this and the original prototype, which you see back there, I've added the ability or the option for shorter struts. This is 1 inch shorter and lowers the wing. It requires an 8-inch prop, so you got to select the motor that I'm using, similar to this one right here. You might be able to get away with a 9-inch prop if you're mindful of the wires here, or the cables. This right here is the Q-Lite OSD. It works with the older DJI Air units and Vistas, and the goggles that I'm using to give me my OSD. I also have GPS back there, and I'm using the TBS Crossfire for long range, the 900 megahertz. Just got done doing the flights, and hope you enjoyed it. I'm overall super happy with the build. The one thing I expected to notice a little bit of difference on the shorter struts. I really didn't notice much difference in the flight, but I'm looking forward to flying a little bit more and getting some more time on it. The other thing is I need to get the wing straight. Either that or I'm going to build a new one. It is crabbing a little bit in the air and it makes it a little uncomfortable coming in for landings. But overall, I hope you've enjoyed the video. I hope you enjoy the build itself. If you have any questions, or I haven't covered something that you have questions on, please post in the comments down below. If you enjoy this content, please subscribe. It helps me out. Share this video with others. Give it a like and a thumbs up. And thanks for watching.